So greedy search algorithm, as I have discussed, there are two types of algorithm which falls into best first strategy. One is called greedy best first search, and second one is called asterisk best first search. So first we will discuss the greedy search algorithm. In the greedy search algorithm, the evaluation function uh, HN, which is based, the evaluation function is totally dependent on the heuristic function. It means here, whenever we generate the nodes, we make the decision only on the basis of the heuristic, only on the basis of heuristic. So whenever we are making decisions only on the basis of heuristic, sometimes it works well, but it is not necessary that you always get the best decision. So for an evaluation function just based on heuristic, so that is why we call it greedy, because given the straight line distance in this problem, if you just consider the straight line distance, does not mean that it always works very well. For example, at right now we are at UBIT, and beside us there is KIPG. So if we make different departments as different locations in the university, the straight line distance from Department of Computer Science UBIT to KIPG is very little compared to the other departments. But if you go for the actual distance, you have to go to the pharmacy, and then you have to take left, and then you'll go to the food science department, and then you will reach out to the KG. So the actual distance is different. That is why we apply the SLD over here. But whenever we make decisions only on the basis of heuristic function, so there is always a greed involved. So that greed actually basically sometimes help us to the solution, but sometimes it will not work very well. But at least heuristic से एक फायदा जरूर ये होता है कि हम अपने स्टेट स्पेस को शॉर्ट करने में कामयाब हो जाते हैं, हम अपने स्टेट स्पेस को रिड्यूस करने में कामयाब हो जाते हैं, और किसी तरीके से हम जल्दी सोल्यूशन तक पहुंचने के काबिल हो जाते हैं. That is why we are using heuristic functions. So remember that in greedy search we just based on the heuristic function. In the given problem, that heuristic function is a straight line distance from any state to the Bucharest, because in this problem the target or the goal state is Bucharest. Last line, if you see, the greedy search expands the node that appears to be closest to goal. That is why we use the term appears to be. Because if the straight line distance is less, it does not mean the actual distance is less. Maybe the actual distance is much more than the SLD. That is possible. But it seems, it looks like that if the straight line distance is less, go for that path. Maybe we reach goal earlier. Later we will see, we will find out whether our decision is correct or our decision is wrong. That is based on the evaluation of the strategy. Okay. Now, by using this strategy, of course, the initial node. What is the initial node? We have the initial node as array. So my array is the initial node. So what is this 366 is representing? That 366 represents the straight line distance from array to Bucharest. Now we have to expand the array. When we expand the array, we have three nodes. One is called Sibui, second is called Timisoara, and third one is called Zerent. These three nodes are expanded in the first step. So if you follow the same heuristic, that SLD information which is given along with this network, from Sibui to Bucharest, the straight line distance is 253. From Timisoara to Bucharest, the straight line distance is 329. And from Zerent to Bucharest, the straight line distance is 374. So here we will opt for the node which appears to be closer to the target state. If you see that these three values, that Sibui seems to be closer to the goal, seems to be, appears to be, not necessarily that it is clear, but In this strategy, we just based on the heuristic function. So what we do? What we do is that we explore the Shibui. When we explore the Shibui, we get the arete, the Phagaras, the Oradia, and the Rimasuvilcia. All these values are representing SLD values. From arete, it is 366. From Phagaras, it is 176. From Oradia, 380, and Rimasuvilcia, 193. So the same principle will be applied. We explore the node which appears to be closer to the goal. Now, because this value is lesser, 176, that appears to be closer to the goal. So we move forward. When we move forward, we reach out to Bucharest. You see in the Bucharest, the number which is representing Bucharest is 0, the SLD value. Why? Because the straight line distance is representing the distance from any node to the Bucharest. So from Bucharest to Bucharest, the straight line distance is 0, of course. If you are at that particular state and you want to know the distance to that particular state, that always be 0. So in that problem, when you have applied the heuristic strategy, heuristic best first strategy, or greedy best first strategy, your solution is what? Now solution is always a sequence. So this, what is the sequence? From arete to Shibui, Shibui to Phagaras, Phagaras to Bucharest. That is your solution, which came out by using the greedy function. Now going back to the table again. So what was the solution? Arete to Shibui, Shibui to Phagaras, Phagaras to Bucharest. That is the path which you have discovered using the greedy function. So if you want to add the actual values, तो जरा actual values को add कर लेते हैं. 140, 99 and 211. So 140, 99 and 140, 99. So that is 140, 99 and plus 211. That is like this, huh? How many is this? 310, 350, 450, I guess, if I am right. So the actual distance, so you can say that the solution is from arete to Shibui to Phagaras to Bucharest. That is the solution. Okay? That is the solution you have, and that is what these values. 450 is what is the actual distance. It is not the straight line distance, it's the actual distance. And this we have done for the greedy best first search. This we have used by using greedy best first search. And the greedy best first search, we only rely on the heuristic function, as we did in this problem. So in this problem, what is the heuristic function? We have used the heuristic SLD as the heuristic function. So going back to the topic again, I hope that you understood this concept. If you have any queries, you might send me on chat, or if you don't have any queries, then I'll proceed. So that is the greedy search. Now, there are 4 concepts which are important for every strategy to be checked, that I have discussed in chapter number 3. Maybe I don't know whether I have discussed it with you. There are 4 important properties which are number 1, completeness. Number 2 is optimality. optimality. Number 3 is time complexity, and number 4 is space complexity. So completeness refers to uh, if you apply a certain algorithm or a strategy to a problem, and if solution is there, your strategy must find the solution. If this happens, then you can say that particular strategy or an algorithm is complete. If solution exists, your algorithm must find the solution. That is completeness. What is optimality? Optimality is called the least cost solution. Let's suppose you have more than one solutions, or you have find the solution, but that solution is not the least cost solution. तो ऐसा भी हो सकता है. If solution is not the least cost solution, then you can say that algorithm does not fulfill the property of optimality or is not optimal. And if your algorithm or strategy always give you the least cost solution, then you can say the strategy is optimal. Time complexity refers to approximate number of nodes generated in a given problem. Time complexity refers to number of nodes generated in a given problem. So in a tree, how many nodes will be generated? इस algorithm को apply कर रहे हैं, कितनी node generate होंगी? Number 4 is the space complexity. Space complexity refers to the amount of memory required to keep those states at one point in time. So at one point in time, how many states you want to keep in the memory? What is the worst case scenario? The worst case scenario is that all the nodes you have generated, you have to keep them in the memory. That is the worst state. And the best state is only the fresh node that you want to keep in the memory. तो इसमें आप best case scenario भी निकाल सकते हैं, worst case scenario भी निकाल सकते हैं, और average case scenarios भी निकाल सकते हैं. ठीक है, these are the 4 properties which we have. So every algorithm is evaluated on the basis of these 4. So completeness, no, it is not complete. Why? Because in these problems, the algorithm might stuck in loops. Why loops? Because whenever we are converting the network diagrams into tree diagrams, then you have repeating nodes, because when you expand array you get Shibui, but when you expand Shibui you might get array, and again in the next node the same thing will happen. So these repeating nodes might create the problem. So if you stop the repeating nodes, then you can say it is complete. But by having the repeating number of nodes in the given problem, you might stuck. The time complexity is b raised to the power m. What is m? M is called the maximum depth. And what is b? B is called the branching factor. So if branching factor is 2, it means there are average 2 nodes, 2 leaf nodes in that tree. If your branching factor is 3, it means there are average 3. On average, there are 3 branches for each particular node, or 3 leaf nodes for each particular node. So here the time complexity is b raised to the power m, since it is represented with big O b raised to the power m. Why? Because we are dealing with the polynomial. When we calculate the possible number of states, so how we calculate the possible number of states? We calculate the possible number of nodes like this: 1 plus b plus b raised to the power 2 plus b raised to the power 3 plus b raised to the power 4 plus ... Then you can say the plus b raised to the power d. That basically is a polynomial. That b is what? B is the branching factor. That might be 2, that might be 2.5, that might be 3.6, that might be 8, that might be 10. So in a given tree, whenever you are looking for the possible number of nodes, then that b factor is very important, because by using this b factor you can compute the possible number of nodes. So here the time complexity is b raised to the power m. Thus we have to keep all the nodes in the memory. Why? Because we don't know where the solution is. So we have to keep all the nodes in the memory so that whenever we reach out the solution, we can represent it as a sequence of states. So if we will not keep those states in the memory, then we might lose the path. So मुझे path ही नहीं मिलेगा, तो I have to represent that path. Optimality? No, it is not optimal. Generally, the greedy best first search algorithm is not optimal. Why? Because we reach to the solution, fine, we get the solution, but not necessarily that solution is always an optimal solution. So it helps you to give you the solution, but not make sure that the given solution is always a least cost solution. These are the properties of greedy best first. After these properties of greedy search algorithm, now we move towards the second algorithm, which is very important in this chapter, that is called asteric search algorithm. Asteric is also called asteric best first, because we have categorized best first search into two categories. One is called greedy and other one is called asteric. What is the basic idea in the asteric search algorithm? The basic idea is avoid expanding paths that are already expensive. So in this problem, whenever we expand the tree, we always avoid the expensive path. तो जो मेरा path expensive होता चला जाएगा, मैं उसे छोड़ता जाऊंगा. जो सबसे less expensive होगा, उस path को मैं continue करूंगा. In asteric search, the evaluation function is based on two things. Evaluation function fn is equal to gn plus hn. Now this is very important to understand. I need your focus, please, and try to comprehend it, because then it will be difficult for you when I solve the problem. So the evaluation function is what? Is actually a function which is based on gn plus hn. Now we try to understand what is gn. gn means cost so far to reach n. किसी भी state तक पहुंचने की cost of reaching to a particular state is called gn. And what is hn? hn we know. What is hn? hn is the cost from that particular straight line distance from that particular state to the goal state. In this case, that is Bucharest. And what is fn? fn is the total cost. So basically here the two costs which are relevant, those are called gn and hn. Try to remember these things. I will give you the concept from the diagram so that you can understand. This one, this is the diagram. Now let's suppose we are starting from arid. So arid, say gn kya hoga? Gn means, because we are at arid, from arid to arid the gn is 0, and from arid, और इसका hn क्या होगा? hn इसका क्या होगा? That is the straight line distance. So from arid to Bucharest it is 366. So when I compute the value, that is 0 plus 366, that will be 366. Now when I generate the successors, so what are the successors of arid? One is Timisoara, one is Sibui, one is Zarin. These are the three successors of arid. Now let's take an example from arid to Zarin. So from when I reach to Zarin, what is gn? gn means cost so far to reach Zarin. So Zarin tak pahunchne ki cost kitni hai? That is 75. That is your gn value. And what is hn? hn is given over here. Zarin is 374. The value will be 75 plus 374. Now let's take this example. From arid to Sibui. On Sibui, at that particular state, the value of gn will be 140, because the cost so far to reach Sibui, that is 140. And from Sibui, you can see over here, that is 253, the straight line distance. So 140 plus 253, that is your fn is equal to gn plus hn. So gn is 140 and hn is 253. Similarly here, if you see the Timisoara, cost so far to reaching to Timisoara is 118, and from Timisoara you can see over here 329. So you add up 329 and 118. So that will be the total cost over here. Then we compute which path is less expensive out of these three. So जो less expensive होगा, we will proceed with that particular path. So now we will see how we will expand nodes in the case of asterisk search. Now start with the arith. So from the arith, the GN is 0. Why? From arith to arith, the GN is 0. And from arith to Bukharis, the straight line distance is 366. So the total cost here at the arith is 366. Now in the next step, I reach out to three possible states. One is called Sibui, second is called Timisoara, third is called Zerend. The calculation is done in the same manner. 140 is the GN value, 253 here is the HN value. In Timisoara, 118 is the GN value and HN value is 329, which is given in the table. From Zerend, 75 is the GN value and 374 is the HN value, and then these values will be summed up. Now, which path is the less expensive path here? So we can see easily the less expensive path is Sibui. So we explored the Sibui. When we explored the Sibui, we get three new states. One is called Fagaras, second is called Oradia, third one is called Remusovilsia, and fourth of course Arith itself. So from Fagaras, when we reach from Sibui to Fagaras, the GN value is 239, HN value is 176. From to Oradia, 291 is the GN value, 380 is the HN value. From to Remusovilsia, 220 is the GN value, 193 is the HN value. And from Sibui to Arith, the 280 is the GN value plus 366 is the, so you get the totals. Now, if you see all the totals, there are actually 6 paths which are unexpended right now. From Sibui to Arith से आगे unexpended है, फिर Fagares से आगे unexpended है, और Oradia से आगे unexpended path है, Remusovilsia से आगे unexpended path है, Timisoara से आगे unexpended path है, Zerend से आगे unexpended path है. Here you have to pick out the less expensive value. Now the less expensive value, the arrow is pointing out, is Remusovilsia. So we'll expand the Remusovilsia. We expand the Remusovilsia, we get three new states. One is called Craiova, Pitești, and Sibui. Now, again, the same GN and HN values are being calculated. The HN and GN values, when we have calculated these values comes out to be 526, 417, and 553. Now, these three paths are unexpended. These three paths are unexpended. These two paths are unexpended. Now we have to look for these the lowest unexpended value. Now, which one is the lowest? If you see the red mark over here, you can realize that 415 is the least cost value we have, the least expended path we have. That is 415, because it is 415, it is 417, and all other values are greater than that. So we expand the Fagaras. When we expand the Fagaras, we reach out to Bukharest. You see, here we reach out to Bukharest. The value is 450. In this algorithm, when you get the goal, it is not necessary that you stop over there. You will find out, is there any other path where we have lesser value than this value which we have achieved? Here we have achieved 450. So there is one unexpended path, that is Pitești. Here the value is 417. So we will also expand this as well to see how we will move on. So when we expand this, we also reach out to the Bukharest. Now here the cost is 418. Now let's see, is we reach to the goal? Is there any state where unexpended path where we have value less than 418? Yes, 615, no. 607, no. 553, no. 526, this one, this one, this one, this one, even this one, no. So there is no unexpended path where we have less value than 418 and we have already reached out to the Bukharis. So that is our goal. That is, it means that we have achieved our goal by using asterisk. तो मेरा पाथ क्या बना? एरिड से सिबुई, सिबुई से रिमिसोविल्सिया, रिमिसोविल्सिया से पिटिस्टी एंड पिटिस्टी से बुखारिस्ट. और जब हमने ग्रीडी सर्च यूज किया था, then at that time we have from arid to Sibui, Sibui to Fagaras, Fagaras to Bukharest. ये वाला पाथ मिला था. Here we have this path. So from arid to Sibui, Sibui to Remisovilcia, Remisovilcia to Pitesti, and Pitesti to Bukharest. So this is the way we have achieved the asterisk search algorithm. So you might check that what is the cost, actual cost of this path. तो आप ये निकाल सकते हो. You have the tree with yourself. आपके पास ट्री है, इस ट्री से निकाल सकते हैं. एरिड से सिबुई, सिबुई से रिमिसोविल्सिया, रिमिसोविल्सिया से पिटेस्टी, पिटेस्टी से बुखारिस्ट. तो ये कितना है? 140, 140 and 80. That is 220. That 220 and 100, 320, 321, 321 and 7, 328, 328 and 90. That is 418. That is the value of this path. And the value which we have achieved from by using the greedy first search algorithm, that was 450. So remember one thing, that the asterisk search always give you the optimal solution. So that is the advantage of using asterisk search algorithm, that always give you the optimal solution. And here we can see it, the properties. Complete? Yes, that is complete. Unless there are infinite many nodes. सिर्फ इस केस में ऐसा हो सकता है. Otherwise, whenever there is a solution, you will always find a solution by using asterisk search. Time complexity, that is exponential in relative error in h into length of the solution. तो अब मेरी हाइट कितनी है, यानी डेप्थ वैल्यूज कितनी है, उस पर डिपेंड करता है. उसका एक्सपोनेंशियल ले लेंगे आप, जो भी वैल्यू है. स्पेस कीप्स ऑल द नोड. ये भी क्या करता है? कीप ऑल द नोड्स इन द मेमोरी. व्हाई? बिकॉज we have to keep all the unexpended paths. So when we have to keep all the unexpended paths in the memory, so we have to keep all the nodes in the memory. Optimal? Yes, it is always optimal. Whenever you apply the asterisk search, unless you make mistake in the heuristic or any other thing, that will be your mistake. But otherwise, asterisk search, when you applied it in the right way, it always gives you an optimal solution. So there is no other way कि हम इसमें optimal solution ना मिले. ठीक है? Now with this, I finish this first part of the chapter, and